In this video, we're going to be solving trigonometric inequalities. So let's say for number 1 that we have sine squared of x plus cosine squared of x minus 1 divided by cosine of x minus cosine 3 of x plus sine 3 of x minus sine x is less than or equal to 2 times cosine of x. And this is going to be on the interval of 0 to 2 pi. So basically, we can simplify this using a double angle identity, and that's going to be sine 2 of x, so this is a 2, plus cosine 2 of x divided by, and then you can also simplify this as well, these two. So this is going to be 2 sine 2 of x times sine of x, and then this is going to be 2 cosine 2 of x times sine of x divided by equal to 2 cosine of x, and this is the unchanged side, and then you have 2 sine 2 of x plus cosine 2 of x divided by, factoring out 2 sine of x, you have sine 2x plus cosine 2x, and this is going to be less than or equal to 2 cosine of x. Now we have a common factor in the numerator and denominator, so that's not 2. And then we can cancel out this. So this just leaves us with 1 over 2 sine of x, and we can basically rewrite this as this. We can rewrite this as 1 less than or equal to 4 sine of x times cosine of x by simply multiplying both sides by 2 sine of x. Now after this, we have sine, so we can simplify this down to sine of 2 of x is less than or equal to 1/2, and we know that 1/2 is equal to pi over 6. So now we can rewrite this as that's going to be sine pi over 6. So now we can rewrite this as 2 of x is going to equal to pi over 6 plus 2 pi k, and then now we have to divide everything by 2 to cancel out that 2. Now this is going to be x is equal to pi over 12 plus pi k, and then we are also going to have 2 of x for our second solution. We're going to have 2 of x is equal to 5 pi over 6 plus 2 pi k. And for this solution, you're going to have to divide by 2 as well. So cancel those out. Then you have 5 pi over 12 plus pi k. And then this is just going to equal to 5 pi over 12, 17 pi over 12. Okay, so now that's going to be x, and this is going to be pi over 12, and then this is going to be 13 pi over 12. Now, those are going to be your solutions. Now, let's do another problem. Let us do this problem. So let's say that we have this problem, question 2. Cosine 3 of x is going to be equal to 3 over 2. Now we can next do this. We have 3 of x is equal to plus or minus pi over 6 plus 2 pi k. So this is within 0 is less than or equal to x less than 2 pi, and also 3 of x is going to be, then it's going to be 0, 6 pi. So you would use k is equal to 0, 1, and 2. So this, therefore, we get that 3 of x is going to be negative pi over 6, pi over 6. Okay. Yeah, this is going to be exclusive. And we also get 11 pi over 6, 13 pi over 6, and then we get 23 pi over 6, 25 pi over 6. Now, we're going to do our boundary points. So now we're going to have to divide by 3, meaning that we have to cancel that, and that means we have to multiply in the denominator 3 to each of these. So this is going to give us x is a part of the subset of negative. Okay, so this starts with pi over 18, or we can just write x first. Pi over 18, pi over 6, 11 pi over 18, 13 pi over 18 is a solution, 23 pi over 18 is a solution, and 25 pi over 18 is a solution. So that means our intervals are going to be from 0 pi over 18, and then we also have pi over 18 to 11 pi over 18. Oh, and then we have 11 pi over 18, 13 pi over 18. We have 13 pi over 18, 23 pi over 18. We have 23 pi over 18 to 25 pi over 18. And then finally we have 25 pi over 18 to 2 pi. Okay, and now we can draw our number line. Make it a little big so that you can see all these values. Okay. 0, 11 pi over 18, 13 pi over 18, 23 pi over 18, 25 pi over 18, and then 2 pi. Okay, so now we have to label our signs. Now we have to test stuff. So now we have to label signs for the function. So we can do, for each of our intervals, we can do 4, 5, 6. How many intervals is this? 1, 2, 3, 4, 5, 6 intervals. And we can start with x is equal to 0. So we have cosine of 0 minus 3 over 2 is going to be greater than 0, so it's going to be positive. X equals to pi over 6. That's going to be cosine pi over 12 over 2 and minus root 3 over 2. That's going to be less than 0, so it's going to be negative. And then you have x is equal to 2 pi over 3 cosine 2 pi minus root 3 over 2, which is going to be positive. And then we have x is equal, and now we just know that the pattern, we can recognize that it's flipping from positive to negative, so that we know that the pattern is going to alternate. Pattern will alternate for intervals. therefore we can write out the sign map. So, okay, we have starting off positive, negative, positive, negative, positive, negative. Great. So now we want, for our solutions, we want greater than 0, positive, and you want to keep them positive. So that means that we can write our solution based off of this as including 0, pi over 18, union of 11 pi over 18, 13 pi over 18, union 23 pi over 18, 25 pi over 18. And yeah, so that's it for this question. So now we can do our next question, which is gonna be question 3. So for question 3, we have sine of x plus pi over 3, and this is gonna be greater than or equal to 1/2. So now we can start off by isolating everything. So we have sine of x plus pi over 3 minus 1/2 is greater than or equal to 0. So now we're going to let f of x equal to sine of x plus pi over 3 minus 1/2. So now from this step, we can basically do sine of x plus pi over 3 is equal to 1/2. And then we can transition this to being x plus pi over 3. And then this will give, for solutions, we can get, for x pi plus pi over 3, we get pi over 6 and 5 pi over 6 mod 2 pi. Now we can set our boundaries in 0 is less than or equal to x is less than 2 pi. So within this interval, we get that x is equal to 0 and pi over 2 and 11 pi over 6. And remember that this comes from 5 pi over 6 minus pi over 3. And then that this comes from negative pi over 6 plus 2 pi. And then, yeah. So for our intervals, we can write that 0 it's including 0 to pi over 2, excluding pi over 2 to 11 pi over 6, including 11 pi over 6 here to 2 pi. And for our signs, we can label this after we do our test points. So we have 0, pi over 2, 11 pi over 6, and then 2 pi, and then we can test some of our values. So we have x is equal to pi over 6 for 3 intervals. We will have our x values. So let's have sine of pi over 2 minus 1/2 is greater than 0, so that will be positive. And then sine of 4 pi, which is going to be 240 degrees, minus 1/2, that's going to be less than 0, so that's going to be negative. And then let's say we have sine 23 pi over 12, so that's going to be 9 pi over 4 minus 1/2, so that's going to be greater than 0, so then this answer will be positive. And we want, for our solutions, we want it to be greater than or equal to 0, but you want to keep it so you want to keep it positive and inclusive of boundaries that are equal to 0. So now you have 0 pi over 2 union 11 pi over 6 to 2 pi. Now, can box that? Okay, great. So now we can move on to our third question, which is gonna be 3. So cosine of x over 2 is less than root 2 over 2. So now isolate this by getting cosine x over 2 minus root 2 over 2 is less than 0. So now we're gonna let f of x equal to cosine of x divided by 2 minus root 2 over 2. Now for cosine x over 2 equals to, we can rewrite this as x over 2 is equal to pi over 4, since x over 2 is going to include 0 to pi because of the fact that x was 0 to 2 pi. So essentially what you did was just divide everything by 2, and then that was where that came from. So now we can, for our intervals, we're gonna have 0 pi over 2, and we're gonna have pi over 2 pi. So now for testing, we're gonna have x is gonna be equal to pi over 3, and we're gonna have cosine pi over 6 minus root 2 over 2 is gonna be greater than 0. That's gonna be positive, and then x equals pi. We're gonna have, for interval 1, interval 2, we're gonna have cosine pi over 2 minus root 2 over 2 less than or equal to 0, so that's gonna be negative. And now we can label this, and we want our solution to be less than 0, so that means we want it to be negative. So that means we're gonna have the interval of pi over 2 to 2 pi as our solution. And let's just graph that quickly on here. 2 pi and pi over 2, 0. Okay, so that's gonna be positive, and this is gonna be negative, and this is gonna be like this. That's gonna be exclusive. Now let's move on to our next problem. This is gonna be problem 4. So for question 4, we have tangent of 2x is going to be greater than or equal to the square root of 3. So now we're going to just let f of x equal to tangent of 2x minus the square root of 3. Now the equation, this is a note for the equation, and also undefined. So what this means is that you need to know that tangent of 2x is equal to the root of 3 when we create it as our function, and then we solving for the pattern of the input as one of our strategies. We have 2 of x is going to be pi over 3 plus pi k. This is for the asymptotes. This is equal to the asymptotes equation for asymptotes is when tan x is undefined. So that's when it's undefined. But we know our boundaries. But we know that our boundaries are in 0 is less than or equal to x is less than 2 pi. So converting, so that means you have to convert to x. We solve in terms of x. We are not solving in terms of 2x. So always remember that when you have you have to manipulate your input back, and you have to do division or whatever they want you to do. So you're gonna have 2 of x is equal to what is this? pi over 2 plus pi k. This is also when it is tan x is also undefined here as well. So make a note of this. So, oh, wait, did we just, yeah, hold on. So, for boundaries, let's actually, like, move this here to put this right next to here. Okay, so now let's, list x in our domain. So what you're gonna do is from tangent 2 of x is equal to the root of 3, you're gonna have x is equal to pi over 6, 2 pi over 3, 7 pi over 6, 5 pi over 3. But we know that it is undefined at x is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So now we're going to want to split the intervals. Split those intervals in order. So that's going to be pi over 6 is less than pi over 4, 2 pi over 3, 3 pi over 4. These are just like unit circle angles in radians. So you should know these. 7 pi over 6, 5 pi over 4, 5 pi over 3, and 7 pi over 4. So the good region, so our desired region for tangent is greater than the root of 3 in each period is going to be it's just going to be 2 of x is, again, the formula from above, pi over 3 plus pi k, and pi over 2 plus pi k. Now, we have, we're gonna add the sign labels for f. So in each period, tan of 2x increases and is negative before you're factoring, hitting root of 3 is equal to 0 at root of 3 and is positive, meaning f is going to be greater than 0 until the asymptote. So that's like what it looks like this, basically. So the positive satisfying intervals are going to be this. So x is going to be the interval of pi over 6, pi over 4, 2 pi over 3, 3 pi over 4, 7 pi over 6, 5 pi over 4, 5 pi over 3, 7 pi over 4. So, yeah, that's just going to be your final solution for this problem. Is a little bit different, but, okay. So, let's do tangent of x is greater than 1 for question 5. So let's let f of x equal to tangent of x minus 1. So we're gonna have tangent of x is equal to 1, and then for this we're gonna have the asymptote, or is gonna be, the pattern is gonna be like x is equal to pi over 4 plus pi k. And now we're gonna have for our boundary, also we have undefined at, okay, this is undefined at x is equal to pi over 2 plus pi k. Or this is the pattern. That's the pattern for this, I realize. And also up here, this is the asymptote equation right here. That's when it's undefined. And this is the pattern for tan repeating. So that's like the repetition. Okay, so now let's talk about our boundaries. This is gonna be on 0 less than x, 2 pi. So we have x is equal to pi over 4 and 5 pi over 4. But this is undefined at, these are our asymptotes. X is equal to pi over 2, 3 pi over 2. So our intervals are gonna be gonna be 0 to pi over 4, pi over 4, pi over 2, pi over 2, 5 pi over 4, 5 pi over 4, 3 pi over 2, 3 pi over 2, 2 pi. And now we have sign labels. We're gonna do our sign labels for for f, and now we're gonna have, for our intervals, we're gonna have 5 intervals, 3, 4, 5, 6. Now for this, we're gonna have, we're gonna have, start with x is equal to pi over 6. So we're gonna have tangent is gonna be less than 1. So therefore we're gonna have f is gonna be less than 0. So that's gonna be negative. And then x is equal to pi over 3. Tangent is gonna be positive, and then f is gonna be greater than 0, so that means it's gonna be positive. So if x is equal to pi, though, you're gonna have that tangent is equal to 0, and then you're gonna have f is gonna be less than 0, so that means it's gonna be negative. And then x, if it's equal to 4 pi over 3, then you're gonna have tangent is greater than 1, and then that's gonna give you f is greater than 0, which means that it's gonna be positive. And then let's say that you have x is equal, there's only 5 intervals, 11 pi over 6, that's gonna give you tangent is gonna be less than 1, and then that's gonna be f is less than 0, so that means it's gonna be negative. So we want it to be greater than 0, but we want it, so that means we keep positive, which means that our solution is going to be pi over 4, pi over 2. Those are our positive solutions. Pi over 2 union 5 pi over 4, 3 pi over 2. So now we can, I think we're good.